Mission 8, Experiment 2. We're going to do a repeat of Experiment 1. The microcontroller has been changed to detect arbitration loss conditions on the Exp2 bus. Alright, the robot's setting up. So during Experiment 1, the problem was the compass stopped working after the 4th waypoint. And so what I did was I changed the I2C drivers to detect bus arbitration loss in case that was the cause of the problem. We'll see if it's any more reliable this time. Now it looks like the robot, Manny, has reached waypoint 1 and is now heading towards waypoint 2. Again, this is Mission 8, Experiment 2. So another update to the Ferris middleware here is that if any of the sensors stop reporting data, for example the compass or the GPS, the robot is just going to stop. But there's a log that's being recorded so that we can later analyze and figure out exactly why the robot stopped. This is Mission 8, Experiment 2. It just reached the 2nd waypoint, now it's going to be heading towards the 3rd waypoint. Everything seems fine so far. Mission 8, Experiment 2. Oh, another change was I changed the Ferris middleware so that it would try to accelerate a little bit more aggressively, because I noticed that on Experiment 1 the robot was accelerating extremely slowly, and I think that was because I added a dampener in the microcontroller code to prevent the motor from accelerating too fast. And that's to prevent the motor battery from becoming triggered, since there's a 6 amp limit on that. Alright, it just reached the 3rd waypoint, now it looks like it's heading towards the 4th waypoint. So far so good. This is Mission 8, Experiment 2. This is the robot reaching the 4th waypoint. We're doing the lollipop waypoint following at 2 meters per second, 4-second pause time. The robot's moving, is just reached the 4th waypoint. Notice that it slows down as it reaches the waypoint. The Ferris middleware has been enhanced so that as the robot reaches a waypoint, it slows down, and it also, by slowing down, it's able to turn at a faster rate, so that it's more likely to reach the waypoint. Now, one thing that hasn't been done yet is if it misses the waypoint, or if its waypoint is at some angle that is sharper than the turn radius, then the robot cannot back up to try to get to that waypoint. That's one of the to-do items. Alright, looks like it's approaching the 5th waypoint. This is further along than it was able to reach on Experiment 1. Again, this is Mission 8, Experiment 2. There's a 4-second pause here. Now it looks like it's heading towards the 6th waypoint. So far so good. You can see that the robot is under pretty good control. It's not swerving or anything. It's pretty much going a dead straight path, you know, perfectly straight path to the 6th waypoint. It's slowing down. I think that's because it's approaching the 6th waypoint. Alright, the 6th waypoint has been reached. We're heading towards the 7th waypoint. This is Mission 8, Experiment 2 with Manny, using the upgraded version 3 of the Ferris player driver, as well as the Proteus microcontroller version 3, completely revised using hardware interrupts for just about everything. slowing down because it's trying to get to the 7th waypoint. That was interesting. It completely stopped for a brief second before heading forward a little bit. It's still moving a tiny bit forward. Okay, it stopped. I think this is the 7th waypoint. Mission 8 Experiment 2. 7th waypoint reached. It's now doing a 90-degree turn. It's heading towards the 8th waypoint. So far so good. Now the reason why Manny is being used is because Manny is the one that gave us all sorts of problems during the last mission. He'll get stuck in the circle of death all the time. Now I don't think the circle of death is possible anymore because instead of adopting a pull-based model, it's now using a push-based model for sensor data. So if the sensor crashes, no data is going to come in, and then the Ferris middleware is just going to stop the robot from running. Before, in the pull-based model, the Ferris middleware would attempt to fetch the sensor data, and if the sensor wasn't responding, it would just return the old data. And that's what caused the circle of death, is the data wasn't being updated. For example, the compass data was the same all the time, and then that caused the robot to just run in a circle. Okay, now I think we're going towards the 9th waypoint. Alright, 9th waypoint has been reached, I believe. Let's see, where is the 9th waypoint? It's possible that the robot has stopped working because maybe the compass. Let's analyze the LEDs here. Okay, the LEDs. I don't know if you can see this. Everything seems fine. LED 2 is blinking at a very fast rate. LED 3 is not blinking at all. That indicates the compass is not being read from. So it looks like we have another error condition with the compass. LED 4 is blinking, and that just means that it's safe mode. LED 5 is blinking. I need to go back and check what LED 5 means. And one thing to note is that the orange LED 1 is not blinking. What that means is the microcontroller is still receiving periodic commands from the x86, so the communication between the x86 and the microcontroller has not crashed. Alright, so this is a failed experiment, experiment number 2, mission 8, and it's quite apparent that the compass has stopped working again. Alright, so we're going to terminate experiment 2 right now.